Okay, so today we're also going to be talking about hypothesis testing and confidence intervals where we have two different samples. This time, however, our two samples, we are comparing the means as opposed to a 9-1 where we were comparing the proportions. So we have basically the same requirements we've always had for means, except that it now applies to two different samples instead of to just one. So both samples are simple random. The two samples have to be independent from one another, meaning that there is no grouping between them. One doesn't affect the other one. The values of the population standard deviations are unknown. And both samples have to either have their sample size be greater than 30 or come from normally distributed populations. So this number 3, the fact that the values of those standard deviations are unknown, that leads us to say that we're going to be using inverse t to find the critical values. Because remember that we only use z for means when we know the population standard deviation. So because in this section, part of the requirement is that we don't know them, that means that all of these are going to be t-type tests, which means if we're using the critical value method, we need to use inverse t as opposed to inverse norm. So, as I said before, I would be keeping a running record for your formula sheet for the exam of which tests go with which situations. So the hypothesis test in this case, when we have two means from independent samples, of course it's in the stat test menu, but this time we're going to be using choice 6, which is, oops, nope, copied down the wrong one. Choice 4, sorry, which is the 2 sample t-test. For the confidence interval, we're going to be doing choice 0, which is the 2 sample t-interval. So those are the values we're going to be using in our calculator. Much like with 9-1, because we're pretty much doing the same thing that we've been doing in chapter 7 and 8, I'm really just going to go through one example. So in a random sample of 186 men, data was collected on the number of words spoken per day and yielded a mean of 15,668.5 words with a standard deviation of 8,632.5 words. In a random sample of 210 women, the number of words spoken per day had a mean of 16,215 words and a standard deviation of 7,301.2 words. We are first going to use a 0.01 significance level to test the claim that the mean number of words spoken per day by men, oops, this shouldn't be mean, men, is less than the mean number of words spoken per day by women. So, just like we always have, we need to write out all of our little steps. This is how it's going to ask on the quiz. It's going to ask for each of these things. So, first thing we always do is we write out the claim in symbolic form. Now, just like in section 9.1 where we had P1 and P2, in this case we're going to have mu1 and mu2. So we say claim is that mean 1, which was the men, is less than mean 2. So that's our claim. Remember that our null hypothesis always has an equal. So we're going to do mu1 is equal to mu2 for that. The alternative hypothesis then, in this case, should match the claim. Once we have our claim and hypotheses written out, then we're going to go about finding our test statistics and critical values. So because this is a less than, that means that this is a left-tailed test. So when we are finding the critical values for the critical value method, I should say critical value, there should only be one. We have two if it's a two-tailed test, but this is left-tailed. So our significance level is 0.01, which means that's the area over here on the left side. So we are going to use inverse T. Bring my calculator over here. So, oops, in the wrong place. Second distribution. Inverse T is choice 4 here. Our area is 0.01, and our degrees of freedom, the rule is that we're going to take the smaller of the sample sizes. So in this case, our sample sizes were 186 and 210. So 186 is smaller, so we do N1 minus 1 in this case, so 185. And then it tells us our critical value is negative 2.35. So record that here. So inverse T, 0.01 with 185 equals negative 2.35. Maybe make a note up here for you for degrees of freedom equals smaller n minus 1. All right, so I've got my critical value. Now I'm going to go ahead and run my hypothesis test. So go to stat tests, and again, like it says in the notes, we're choosing choice 4 for two-sample t-test. You will have situations where you have data. We've already gone over how to do data as opposed to statistics. I can't say that word today. So putting in our value, the mean one was, let's see, 15,668.5. So enter that, 15,668 point, can't get my, there we go, 0.5. Then standard deviation 1, 8,632.5. My sample size was 186. Oops, 186. There we go. Then for our sample 2, the women, the mean was 16 to 15. And the standard deviation was 7,301.2. Sample size there was 210. So we're choosing, again, as we always do. In this case, our claim was a less than, so we'll keep it on a less than. Always keep it pooled no, and then press enter. All right, so then our values here, we get our t value as negative 0.68. And then we've got our p-value here as well. So leave those two here so we can see them for a second. So test statistic, negative 0.68. And our p-value was 0.2498, so that'd be 250, really, to 3 significant digits. All right, so now we need to make a decision about our null hypothesis. Again, here I've chosen just to give you both methods, just so we have practice with both in this set of notes. So, critical value method. Remember that the rejection region in this case, because it's a left-tailed test, is on the left side here. So this value right here is negative 2.35. So only values that are below that are going to be in the rejection region. Negative 0.68 is not in that rejection region, so we would say that we are going to fail to reject our null hypothesis in this case. For critical value method, it's because our negative 0.68 is not less than this guy. P-value method, remember that our alpha was 0.01. This p-value is not less than our alpha, so that gives us the same conclusion there. So then we have to write out our final conclusion. So our claim did not include equality, no equal sign. So that means we're going to use support because we failed to reject. That means we say there is not. So not fail. So there is not sufficient evidence to support the claim that mean number of words spoken per day by men, it's not be men, by men, is less than the mean number of words spoken per day by women. You do, as I've said in many of the other lessons, you do need to write the whole thing out. Make sure that you have stated the claim in words in your final conclusion. All right, so last thing is to construct the appropriate confidence interval. And in the last lesson, we kind of introduced how that confidence interval relates to our claims. So it's going to work the same way here when we go to interpret it. Now, before we can interpret it, we have to actually construct it. Remember that in this case, because it is a one-tailed test, we are going to do 1 minus 2 alpha for our confidence level. So our alpha was 0.01, so 1 minus 2 times 0.01, which gives us 0.98. So this is a 98% confidence interval that we are going to construct. So go into our calculator. Again, like we set up here at the top of the notes, we're going to be using choice 0, the 2 sample t interval. So stat tests, probably quicker to go up. Yeah, well, in this case, actually, it probably doesn't matter. Probably just press 0, that would be better. So 2 sample t interval. And again, we have statistics, not data in this case. And double check, but all that information looks exactly like what I just put in. Confidence level is currently at 0.98, so I can leave it. Remember, we are never on this type of test going to use the pooled. So when we go to calculate now, we have negative 2,437 as our lower limit, 1,343.8 as our upper limit. So can go ahead and write those down. Remember that what's in the middle, I prefer to write these in the inequality format because it shows what's in the center, and that's really important in this section. So negative 2,437 437 on the left, and then we have 1,343.8 on the right. So remember, just like what we described in section 9.1. So you can go back to those notes if you want. I'm not going to rewrite out all the things again, but what we're looking for is whether our two boundaries are both negative, one positive and one negative, or both positive. So in this case, we have one negative and one positive. So we would say that since our confidence interval includes 0, we conclude that there is not a significant difference in mean 1 and mean 2. So if there's not a significant difference, that means that they could be the same. If they could be the same, then we can't confidently say less than like the claim. So just like it said here, we didn't have sufficient evidence to support that it's less. We're saying the same thing here in a different way. So again, as long as you're using the same situation, I don't need you to rewrite out the same final conclusion. You can just say same final conclusion as the hypothesis test. This part right here is our interpretation. And this is our final conclusion. All right, that wraps up our section 9.2.